Let's take a look at the underlying structure of all confidence intervals and see how this leads to the different formulas that all essentially resemble one another. Let's break this down. We have a parameter, a population parameter, and that is estimated by, so the confidence interval of the entire population parameter is equal to our statistic plus or minus our margin of error. And our margin of error is made up of the standard error times z star. Let's go ahead and uncover each of these one at a time and try to understand what they mean. The first one is actually saying the confidence interval itself. Whenever you make a confidence interval, you're making an estimate for what is the real mu, the population mean, or the real rho, the population proportion. So this is saying your parameter is your guess of what is the confidence interval for the population. Our best guess for mu or p is going to be our statistic that we collect, x bar p hat. So if we go out and take a sample, we find a sample average or a sample proportion, that's going to be our best guess. So we always start with the statistic and then build our margin of error around that. And that's where we get our guess for the parameter. Now our margin of error has these two pieces. First one is the standard error. And standard error you can think of as essentially standard deviation. After the central limit theorem, when you divide your original standard deviation by the square root of your sample size, square root of n, that is your standard error. For proportions, there's an interesting formula that you used based on a simplification of binomials, where a lot of proportion theory comes from. Again, that's going to be your standard error. So that's a formula that you essentially plug into, but it determines your spread. It determines the standard deviation of your curve. And then the last one is how much of that curve, that sampling distribution, you actually fill in. And so it turns confidence level, such as 95% confidence, into a z-score, such as 1.96. So if you want to be 95% confident, it means that on your normal curve you need to go 1.96 standard deviations out in each direction. That's why you multiply it by the how much each standard deviation is to create your margin of error. To try to think through this a little bit, let's imagine we have this number line down here, and we took a sample. We wanted to guess the parameter. So this whole thing is representing our parameter proportion here, let's say. So that's our population proportion, and we're trying to guess what that is. So we're going to go out and collect a sample, and our statistic says that it is 25%. So this is our best guess at the population proportion, is based on our sample. Now a specific one-spot answer is not very good. We want to do better than that. We want to create an interval so that we have a higher chance of being right. So we're going to take our normal curve and we're going to plop that right in the middle of that sample proportion p hat. Now the width of this curve depends on, when you're talking about proportion, it primarily depends on your sample size. So let's say we have a sample size such that we have a curve that is about this wide here. And once we take this curve, we want to be 95% confident. So if we want to be 95% confident, we would end up filling in within approximately 2 standard deviations, because we know that 95% of the curve approximately is within 2 standard deviations. So if we color in that 2 standard deviations on that curve that came from the standard error, or primarily depends on our sample size, then we can determine what our interval will be. So we draw that down to here, we draw that down to here, and now we have our best guess is within this range. 95% of the time we'll be right if we make a guess for the population proportion in that range. We'll get into specific formulas in the next couple videos that talks separately about means and proportions and get into the actual formulas, but go back to this as kind of a general overview for what we're trying to accomplish.